Hello students, I'm Mr. Ruffler, a high school chemistry teacher, and welcome to the channel. In this series, we're working through the brand new June 2026 New York State Chemistry Regents exam, cluster by cluster. This is the sixth video in the series where we're going to tackle the balloon arches cluster. If you're looking for a different cluster, you can check out the playlist linked in the description below, where you'll find step-by-step walkthroughs of the rest of the exam. Let's get started. As with all clusters, my first step is going to be thoroughly reading this for understanding. So let's go at it. So two groups of students are on the decorating committee for an evening winter dance at their high school in upstate New York. One group decided to make a balloon arch in the interior hallway to welcome the students. The other group decided to make a balloon arch outside on the sidewalk leading to the school door. Figure 1 shows the self-inflating balloons the students chose to use, made from mylar. All right, we can see that this pouch contains sodium hydrogen carbonate inside the balloon. And when you squeeze it, these two reactants are mixing, and then they're producing some sort of gas that's inflating the balloon. But let's keep on reading. So it says that one mylar balloon contained 1.439 grams of solid sodium hydrogen carbonate and a pouch containing a solution of citric acid. When mixed, these react to inflate the balloon. Equation 1 represents this reaction. Figure 2 provides molar masses for the substances in equation 1. So looking at this equation, right, we have the two reactants. They're making water, they're making some aqueous salt, but then they're also producing CO2, right? So this is the gas that's causing the balloon to inflate. All right, it then says the two groups of students noticed that the balloons attached to the outdoor archway were smaller. So if it's outdoors, it's smaller than the balloon attached to the indoor archway where the balloons were inflated. Which graph represents the two factors that cause the difference in the size of balloons on the indoor and outdoor arches? So looking at the graphs, we have to evaluate three different variables: pressure, temperature, and volume. If I'm thinking about this, if you have a balloon inside versus outside, the pressure is not going to be any different, so we don't really care about pressure. And then if the balloon is getting bigger in one setting, that's involving volume, so there must be a temperature differential between indoor and outdoor balloons. Okay, so right off the bat, we can get rid of 1 and 3 because those have pressure and we're not caring about pressure in this scenario. And then between 2 and 4, we have some pretty compelling answer choices. So we don't really know whether it's warmer or colder outside, do we? We can imply that it's probably colder because it's saying that it's a winter dance. However, we probably want to back this up with some evidence based on an equation. So the one equation that's on your reference table that I think of is P1 V1 over T1 equals P2 V2 over T2. Right? If we get rid of pressure from there, we have just a variable over a variable equals another variable over a variable. And then that relationship between volume and temperature would look something like this. Right? The only one that would be curved would be the pressure and the volume relation. Because if we were doing pressure and volume, that would be variable times variable. And then that would look something like this. So this does check up with the fact that, yes, it's the winter and it's a lot colder outside. So we will pick this relationship. Okay, as the temperature is lower, the volume's lower. So this would be outside. And as the temperature is higher, the volume is higher. This would be inside. All right, 24 says calculate the number of grams of CO2 that would be produced when the balloon is completely inflated. All right, so we got to go back to this equation and we need to figure out what is the gram value of CO2 produced. The information that we have is that a mylar balloon contains 1.439 grams of solid sodium hydrogen carbonate. Okay, so we got to do some really fun dimensional analysis here. So I'm going to do all the work on this page because I have the information, but know that we're going from grams of sodium hydrogen carbonate to grams of CO2. This is a dimensional analysis problem where we need to start by writing 1.439 grams of the NaHCO3 over 1. Okay, I like to develop a game plan with my students. So the game plan is I cannot go from grams of one substance to grams of another. I have to go from grams to moles of that substance. And then once I get both of those substances in moles, then I can go between the two substances. So step one is we have the grams of NaHCO3. That has to become moles of NaHCO3. That can then become moles of CO2, and then that can become grams of CO2. Okay, so next step here is let's get rid of grams of sodium hydrogen carbonate and get that into moles of sodium hydrogen carbonate. Then once I have that, I can get rid of moles of sodium hydrogen carbonate, and I can get into moles of CO2. And then I can get rid of my moles of CO2, and I'll be left with my grams of CO2 that the question is asking me for. All right, so then how do I plug in the numbers? Well, it gave us the molar masses, which is really nice. So for the first one, we have 84.01 grams per mole. What that means for that substance is 84.01 grams is equal to 1 mole. So plugging in those numbers, I get this. The next step is then looking at the mole ratio in the equation. So the mole ratio of NaHCO3 to CO2. If we look, that relationship is 3 to 3 or 1 to 1. I'll just plug in 3 to 3. It won't matter mathematically when you solve it. And then the final step is converting your moles of CO2 into grams of CO2. So recall that this means 44.01 grams is equal to 1 mole. So plugging in, I'll get that. Okay, when you do all the math, remember when you're multiplying fractions, you multiply across the top, multiply across the bottom, and then you divide. So your setup will look like this. And when you do all of that, you should get 0.7538 grams of CO2. All right, moving along. One student was inflating the balloons for the interior hallway. As the components in the reaction were mixed, the student noticed that the balloons felt cold. The student read the label on the small self-inflating balloon. The package states that when the balloon is inflated at 25 degrees Celsius and 1.0 atmosphere, the volume will be 135 milliliters. The student measures the volume of a balloon attached to the outdoor archway as 123 milliliters. Then question 25 says, which statement describes the change in energy and the placement of the energy term in equation 1? So what we need to do is figure out if this is getting hot or cold. It says that when inflating the balloon, they noticed that it felt cold. So if it feels cold, this means that it's an endothermic reaction, right? It's taking heat from the surroundings and then it's absorbing that into the system. So in endothermic reactions, you will recall that heat must be a reactant. So let's pick the answer choice. It's not exothermic, so we can eliminate choice 2 and 4. If it is a reactant, we have our reactants plus heat forms our product. So the heat will be on the left side. It's going to be choice 1. All right, question number 26 says, construct a mathematical representation using appropriate calculations that could be used to determine the temperature of the Mylar balloon outside at a pressure of 1.0 atmospheres. All right, so what we want to do is really just go and identify all of the terms in this equation and then plug this into our combined gas law. So I'm just going to write the combined gas law. Now that I have this written, I'm just going to go through and circle my terms here. So it says when the balloon is inflated at 25 degrees Celsius, all right, that has to be temperature 1, but remember that it has to be in Kelvin. So we should do 273.15 plus 25 to give us 298.15 Kelvin. Okay, that is T1. And then 1 atmosphere, that's going to be P1. And then it gives us 135 milliliters. That must be V1. It then says that the student measures the volume of a balloon attached to the outdoor archway as 123 milliliters. That will be V2. And it says that the outside pressure is 1.01 atmospheres. That is P2. And recall, we're trying to figure out the temperature of the balloon outside, so we're solving for T2. Okay, so I'm just going to plug in all those numbers, and I don't even need to solve it. I just need to show a mathematical relationship. You can, because the pressures P1 and P2 are equal, right? They're both 1.0 atmosphere. You can choose to leave this out in your answer. If you keep it in your answer, you also will not lose credit. I'm going to choose to exclude. Actually, no, I'll put it in. Okay, so P1, 1.0 atmosphere. And voila. Through the power of pausing my recording, I decided not to torch you guys with that. So this should be your answer once you plug everything in. Okay, moving along. Balloons can be made from latex or mylar. The students were concerned about which substance would be less harmful to the environment when using balloons in future events. Figure 2 lists some of the characteristics of both latex and mylar balloons. In question 27, it says which material would be a better choice based on trade-offs for short-term benefits and long-term negative environmental impacts. Choice 1 says latex because it is less cost effective. However, the chart says it's more cost effective. So we're going to get rid of that one and just stop reading it. Choice 2 says latex because it is less likely to cause electrical outages. Okay, that's true. But it may contribute to microplastic pollution. Yeah, choice 2 is looking pretty good, but as always, read the other choices and, eliminate them. Number 3 says mylar because it is more cost effective. Well, it says mylar is more effective, so we can get rid of that, or more expensive, so we can get rid of that. And then choice 4, mylar because it is less likely to cause electrical outages. Here it says it's more likely to cause electrical outages. That's a reading question, guys. There should be no reason that you get that one wrong. So that's it for this cluster. I hope this was helpful. If you did find it helpful, please like the video and you can subscribe for more walkthroughs. When you're ready, you can click the next video in the description below. I'm linking the playlist and hopefully it should pop up. Happy studying.